Okay, so let's run our first MapReduce job with Java. To do so, we first need to have a few files available for us. These files can be downloaded from the internet. However, I've made them available in my website, datapower.com. So go ahead and visit website and download in your computer the following files. There is a file named nysc_example.java. This is where we have the Java code. We'll explain the Java code in more details, but for now on, go ahead and simply download it. There is our input file, nysc_data.txt. It's a text file. Go ahead and download that. Also, there is a Hadoop core jar file. You also need that to compile the Java code into a MapReduce task. Finally, we need to have Eclipse for Java downloaded in our computer. Visit eclipse.org/downloads and select Eclipse IDE for Java developers according to your operating system. Now let's compile the Java code into a MapReduce jar file. Let's open in the Finder folder. I'm going to look for the nysc_example file that I downloaded from the website. Here is nysc_example.java. Let's open it to the text editor and select all, right click, copy, and let's close the text file. Let's open Eclipse for Java, search for the program, double click, and wait until Eclipse IDE for Java opens. Select the workspace and click Launch. Open a new project, File, New, Java Project. Let's name the project BDME, or Big Data Made Easy, and in Use an Execution Environment JRE, let's select Java 1.8. The Hadoop cluster that we are going to execute this job runs Java 8. Now, click Next, and then Finish. Let's expand the BDME project. Click on the arrow. Right-click on the source folder, src, New Class. The package is edu.bdme. This is a hierarchy of the class package. And then the name of the class, let's call it nysc_example. Click Finish. A new class will be created for us. Now let's paste the Java code that we copied from the text file and make sure that the package name is the same as the package in the code. So I am going to remove the package.com examples. So I'm going to keep the package edu.bdme, and here is the code. As you can see, there is a lot of errors in this code. The reason for these errors is because this code uses a lot of libraries from MapReduce, which are in the Hadoop core file. So let's bring the Hadoop core.jar file into the program. Let's right-click on BDME, New Folder, and let's create a lib folder, lib. Click Finish. Now let's get the Hadoop core that we downloaded from the website and bring into this folder. So let's minimize a little bit, move it away so we can open the Find. Then let's search for Hadoop core that we have downloaded from the website. let's do this Mac. So Hadoop core is right here. So let's drag this into the lib folder. Click OK. So if you expand the lib, you'll see the Hadoop core jar is there. Now let's configure a path to this jar. Right-click on BDME, Build Path, Configure Build Path, Add Jars, expand BDME, go to lib folder, select the jar and click OK. Apply and close, and you'll see that all the errors will disappear. Let's explore the Java code in more details. At the beginning, we have the import functions. These are a series of Hadoop MapReduce functions. Then we have the public class, which contains the mapper and the reducer. Here is the mapper, and down is the reducer. Let's explore each of them in more details. The mapper. The mapper extends the MapReduce base, which is imported as a library function, and implements a mapper that has parameters long writable, text, text, long writable, basically key value as input, key value as output. This ensures that, in spite of the different approaches to process the data, the interface input-output is always the same. Inside the mapper, there is the map function, which processes the input file one line at a time. As each line is read as a string, the tokenizer, a function, is applied that splits the line into tokens based on a comma, then assigns the ticker value and the trade price value, and emits the ticker and the trade price. And we have the reducer, which also extends the MapReduce base, implements reducer. Input parameters are text and long writable, output text and long writable, again key value in, key value out. The reducer also has a function called reduce, which takes each input line, which, as we said earlier, comes in the form of key value from the mapper, and for each key calculates the maximum price and emits the key and the maximum price as the final output. And then we have the body of the program, which defines the job as a variable conf. The job name is NYSE. Assign specific data types to output key of the conf job. Assign specific data type to the output value of the conf job. Assigns the map class to the mapper of the conf. Assigns the reduce class to the reduce of the conf job. And finally defines the format to input files and the output files. Of course, we need to define the path to input and output file. Then the command to run the job. Before we compile the program, let's note the package name that we defined earlier, edu.bdme, dot class name nysc underscore example, also let's note the name of the jar, nysc dot jar. We will need this information when we execute the MapReduce jar. And now let's compile. Click the project name, BDME, right-click, Export. Select jar file, click Next, come up with a name and a location. You can browse if you want to locate it in a different place in your computer. In this case, it's going to be in Downloads MapReduce folder. You may be asked to save the changes you have made. Click Yes, and the jar file is created. Now that we have the jar file, let's execute it. The cluster is up and running, and let's copy the SSH string, open the terminal, paste. Now we need to make sure that the extension is the correct extension. I believe that when I saved this new key, I had a CER extension. Let's double check. Searching my demo in this Mac, and yes, the extension is CER, so I'm going to make that change. I also add the downloads folder because I know that's where my key is stored. Hit enter, and the connection to the cluster is established. One more quick point here. My demonstration is based on a Mac computer. The instructions for Windows users are slightly different, and they are provided in one of the previous video tutorials. This is a cluster that I have used earlier today. As you can see, there is a MapReduce directory already there. That is an empty directory. Let's do a cd on the directory. ls shows nothing. So let's go back to home directory and ignore the MapReduce. Now we will export the input file and the jar file into the cluster. We open FileZilla. Before entering the information about the host name, let's go to FileZilla settings. On secure FTP, make sure that the key is already there. That's right there, so click OK. We enter the host name. I'm simply pasting the SSH string and then removing anything that is before EC2. The username is Hadoop, password empty, connection port 22, click Quick Connect, confirm, and we are connected. The nysc.jar and nysc_data text are the two files that we need. We simply drag them to the cluster in the Hadoop directory in the cluster. You'll see the files already in the cluster. Now let's go back to the terminal. A quick ls here will show that the files are already there. Let's make sure that the input file has the correct information. Let's do nano on that file. See, the records are there, the ticker, the day, the price. Let's scroll down all the way. Oops, we have some empty lines. We don't need those empty lines, so let's backspace to those and delete those lines. Save the file. So we know that the file is correct now. We need to move this file to the cluster. Hadoop fs -ls will indicate that we already have an MR directory. So let's do Hadoop fs -copy from local nysc_ data.txt mr. So the file moves to the MR directory in the cluster. Here is the command to execute the MapReduce job. We do Hadoop jar, the name of the jar, nysc.jar. Remember, we noted that in the text file. That's where we put there. And then is the class name in the hierarchy mode. So we have edu.bdme.ms nysc_example, the location of the input file, and we have created an output directory. It is important that output does not exist. If you put a directory that already exists, you will get an error that the output directory already exists. Hit enter to execute the job. And here is the MapReduce job being executed. You'll see the counter for the mapper, map 0%, 20%, and then also you should see a counter for the reducer once the mapper is 100%. If you, let's scroll up a little bit so you can see the counter for the reducer. So the reducer from 0 went directly to 100%. Obviously there is not much input data in this example, so the reducer performs it very much faster. So if you can do a Hadoop fs ls mr, we can see that the output subdirectory is already created there. So you can see what's inside the subdirectory with an ls command. You will see the success folder and files where the output. If you do a cat on these files, you will see the results. And this is how you execute a MapReduce job with Java in the cluster. I hope you enjoyed this demonstration. Go ahead and try it, and if you have any questions, do not hesitate to contact me. If you want to learn more about big data analytics, subscribe to this channel. Also, follow me on Twitter at Professor Benny or join my LinkedIn network. You can always email me with any questions.